Hi, welcome to this shorter video about Delay 1, a new bucket brigade delay designed by Joranalogue Audio Design. The reason I'm not doing an extensive playthrough of Delay 1 at this moment is simply because I don't have the time to make it. And if you're curious why on earth that's possible, I'll explain a little bit at the end of the video. First of all, I want to thank the whole team at Joranalogue Audio Design to let me test this prototype version of Delay 1. This also enables me to create a little bit of content before the modules actually are released to the public. So if you know where to look, you will find a little bit of content where Delay 1 is featured. For this quick playthrough, I just want to walk you through the basic operation of Delay 1. Now, let me break the news to you immediately. You should not look at Delay 1 as a regular delay. If you're looking for tempo synced stereo ping pong delays, Delay 1 is probably not the module for you. But it can do a whole lot of other things that you cannot do with most delays. So let me unmute a few channels on my mixer. First of all, this is a kick drum coming from Mandrake. And this is just to give us some kind of reference. Then there's this ping sound. This is coming from filter 8, and we can see this signal on the scope. I used the green cables. It's also the green trace. This signal is going through Delay 1, which is connected to a separate channel on my mixer at the moment. Let me bring that in really quickly here. And let me also unmute that channel. So now you can hear. Let's adjust the volumes here a little bit. So now you can hear and see that the delay time we're getting. And by the way, the coarse knob here controls the length of the delay, and it's actually maxed out when it's to the left here. So this is the maximum delay time that we're getting, as long as you don't send in your own clock here, but I'll get to that later. Now you might think, what the hell am I going to do with this? Well, you can do a lot of interesting things with this. At the moment I'm using the... Can you even see it? No, you cannot. So I was using the delay output. There's two more outputs, but this delay output is always fully wet, so there's no trace left of the signal that we are sending in. And the first thing, and let me just crank up the feedback a little bit. Feedback is, in essence, the delay just feeding back on itself. Well, yeah, now I tried explaining a word with a sentence where the word is used. So let me try that again. We're sending a signal in. It's coming out of this output fully wet, and it's going to wherever I sent it. At the moment, this is my mixer. But internally, this signal, at least when you turn up the feedback, the signal is sent back into the circuit at the input stage. So when you turn this up, you get several repetitions because the delayed sound is fed back into the input. It then gets delayed again at the output, gets sent back in, etc. The biggest difference is that you're losing some gain, and that's why it dies down. Now when you turn the feedback knob completely to the right, we have a feedback amplitude of almost 100%, which means that the delayed signal is going back into the input internally at 99% of its original volume. And this creates these kind of effects. Now, if you fine-tune it, you can get an interesting tail happening. Something like this. And let me mute the signal that we're sending in. I'll hide it here as well. And this is what's called Corpus strong synthesis. And then we can play around with the coarse knob, which now behaves a little bit more like we would expect a coarse tuning knob to behave. And right from the bat, you might be wondering, can I control this with CV? Can I send a pitch sequence into this? Well, yes, of course you can. So let's take a sequence here from Moscow 2. It's a quantized sequence of 6 steps. And we can just plug this signal into the fault proactive input. Now you can hear that this sequence is playing very nicely. Let me change the sequence up a bit. And you can hear that the quantized sequence is, well, it's played accurately. The tracking is spot on. What you probably would expect from a Joranalogue Audio Design module, but I don't think it's a small feat to get this to work on a bucket brigade delay. Let me turn down the feedback a little bit. So you might have a sequence going on your system, and you want to add delay 1 as a voice. And then it's important that you can accurately fine-tune it. Well, that's no problem. There's a fine-tune knob as well, and this has a 10% range of the coarse knob. Okay. Let me remove the sequence. So this is the slowest that it can go. Slowest is also the lowest note. And this is actually exceeding the audible range. The range is quite big actually. I haven't figured out how many octaves this is exactly. But I would think this is really sufficient for most applications. So I will keep using the delay output for now. So again, this is 100% wet blend of the delayed signal. There's this time mod attenuverter. What this does is, well, it's like exponential FM really. So you send something into the time input here, I used a triangle wave coming from channel 3, which is just off screen there. And then you can fine-tune the effect that this modulation has with the knob. When you turn it completely to the right, the amount of modulation is, well, 1 volt per octave. And when you turn it completely to the left, sending in 1 volt will make the pitch go down 1 octave. The signal that I'm sending in is living between 5 volts and minus 5 volts, so we get a huge range from this. If you want to do something like vibrato, probably better to use an LFO that's already attenuated. Something like this. And then when I send in the pitch sequence again, let me tune it down a bit. And you get these cool harmonics whenever well, yeah, the speed of the clock, and it's the clock that's controlling the length of the delay. So whenever this is the same frequency as a sound we're sending in, we get these cool carpless strong harmonics. Let me keep this going while I explain what the damping is for. There's 2 settings for the damping. There's also a CV input with an attenuverter here. When the setting is to the left side, to the low side, there's a low pass filter in the feedback path. So when I told you that internally the delay output is routed back into the input, depending on how much we turn up the feedback, well, there's a low pass filter in between. And as we're still listening to the fully wet blend coming from the regular delay output, it's really clear what this does to the sound. Now if I turn it completely to the right, it's completely dampened. And this does not dampen the initial delay, it only dampens the feedback circuit. Now when I switch this to the right setting, which is the high setting, this knob controls a high pass filter, and it's similar to what we had in the low setting. Turning this to the right dampens the signal in the feedback path. Turning it completely. Now it's way too much fun not to try it out on camera, to modulate this parameter with CV. And by this parameter I mean the damping. Let me sync this LFO to the tempo of the sequence. And now when I turn this knob to the right or to the left, you will hear the effect. And as you probably already saw, there's a CV input for feedback as well, with its own attenuverter here. Let me send in another stepped random LFO to that input. I'm just going to use a regular cable here. Let me sing this one as well. Let me try a unipolar LFO to have a little bit more control. And as you can hear, delay one is a whole lot of fun, but we're not really creating, well, what you expect of classic delays. Let me switch this to the low setting, so the low pass filter in the feedback path. And I think this sounds really cool, so let me add in some reverb. And while I'm at it, let me add some stereo delay as well. Let's unmute the signal that I'm sending in as well. The signal that I'm sending into the signal input here is just a pinged filter 8. Now, what would happen when I send the pitch sequence I have going on here into the filter instead of into the delay line? Let's try it out. You can hear that this delay output here, not really following the pitch, it's just creating delays, well, feedback delays at the rate we set here. But maybe I can mult this pitch sequence. Yes, I can. And let's send it to the delay as well. Well, this is all kinds of fun. Now I'll move over to using one of these outputs. Let's just start off with the positive one. When using one of these two outputs, the setting of the blend knob becomes important. So now I no longer need to mult the signal that I'm sending in to be able to hear it, because the blend knob sets the balance between the dry signal, which is the signal that we're sending in, and this is still the same as before, the pinged filter 8 here. And when we turn the blend knob completely to the right, well, we introduce the wet signal more and more. And when it's completely to the right, we're only hearing the wet signal. There's another switch here, which is currently at the sum setting. And switching this switch to the left, which is the anti setting at this point, the output of the feedback will be phase inverted. And I'm not sure about the circuitry or maths behind this. But you can hear that there's quite a big difference actually. Well, I'm saying big difference. It's a subtle difference, but it's there. This will be more important when we set the blend somewhere in the middle. Let me turn up the coarse tuning here to make the delays shorter. So this is the switch to the right. And let me switch it to the left. There you can really hear the difference. The difference between the positive output and the negative output is simply the positive output is the sum of the dry signal and the wet signal, depending on how you set this knob. And the negative output here is the difference between the dry setting and the blend setting. And this will give you a stereo pair, or you could look at this as something that you can apply mid-side processing to. No matter how you use it, this will give you, if you want it to, it gives you a little bit of stereo separation. So let's, as you can hear, there doesn't seem to be that much of a difference when you just compare them separately. But let me also route this to a different input on my mixer. So no low cut muting, yes. Okay, left, right. So now I have this negative output going into our left ears, and I'm sending the positive output here, and I'll send this to your right ear. There we have it. And you can even see that there's some kind of difference there. You can surely hear that there is indeed some stereo going on. Let me switch to the anti setting here. Well, I think this is really sounding good. Oh, let me turn down the reverb and the delay. I forgot to turn it down. And let's add another slow moving LFO to the time parameter here. Attenuate it a bit more. Let me turn up the resonance on filter 8 so we get more of a continuous sound. And let's turn it down. With turn it down, I mean tune it down. And mind you, I'm just sending in a sine wave. You can get really interesting results when you start sending in saw waves, stuff like that. And I make one here really quickly. So this is clipping my mixer terribly. So let's turn it down. And right now, you can clearly see how big of a difference there is between these positive and negative outputs. They're essentially just, well, at this moment, inverted versions of each other. And when I turn the blend knob completely to the left, we're just getting the signal we're sending in. So it's just completely, well, it's the dry signal and it's mono again. What you can see and hear when I turn this to the right, you introduce that stereo separation that's made possible with delay 1. Let's switch back to the anti setting. Not so much of a difference here. Let's connect the sequence that I used earlier to filter 8 again. Let's tune it down. Oh, I removed my sync cable here. I don't know why. There we have it. And I think you can start hearing where delay 1 shines. This is an amazing module to create choruses, flangers. You know, those kinds of interesting 70s space age, well, 70s isn't really space age, I would think. Anyway, can create these warbly, spacious effects. Let's turn down filter rate. Let's use an LED cable for this, as it's becoming more and more important to be able to follow what's happening. Now it's, yeah, maybe like that. You can see that changing the coarse setting on delay 1 at this moment doesn't really make that much of a difference. Well, if you're not impressed by this, you probably never listened to Daft Punk. So now the knob is completely to the right, which means that we're only getting the wet signal. Let's switch to the sum setting here. Let's listen to this with a little bit less feedback. And I'm just going to play around with the settings here for a few more minutes, so you can get more of an idea how this module sounds. Maybe I should introduce some sidechain compression. This is happening externally. I'm using an outboard compressor for this. So let's first bring in these. Well, this is sounding really great. And let's bring in the dreaded reverb. And maybe the stereo delay as well, which is also an outboard effect. really cool. So let me change up my patch here. The things I still want to show you are, well, the pluck input and the high frequency clock input and output. I changed up my patch a little bit. This LED cable is sending a short gate pattern through the scope. And in a minute, I will connect this to the pluck input of delay 1. And just like on filter 8, with its ping input, Joranalogue made sure to give us something similar here. And this is the pluck input. Now, normally when you would try to pluck or trigger or ping, I don't know what's the correct terminology, when you want to trigger a delay line for coarse strong synthesis, you normally would send really short burst of noise or some kind of pulse into the signal input. But the signal that you send in, it's really finicky to get it to be just right for your particular delay to start ringing like a string. So that's why, and this is similar to what's on filter 8, that's why there's this pluck input here that kind of converts anything that you send in into the perfect trigger for the feedback line in the delay here. So let's send this gate pattern with this tendril cable into the pluck input. And at the moment you can just hear that this gives us, well, a really short burst of noise. And this is what the pluck input is converting this gate pattern into. Now the blend knob, well, I turned the blend knob completely to the left. Let's turn it completely to the right. And I'm using the positive output here. And this still sounds the same. But let's now bring in some feedback. And you'll hear that it starts ringing. And this is just like before, and well, just like with a regular delay. If you turn up the feedback too much, you get this endless looping delay line that you can actually use as a synthesis method. And where I earlier in the video sent in a ping of filter 8, now there's really no signal at the signal input. We're just using this built-in compounder to trigger the delay line. And of course you can still control this with a pitch sequence. Let's bring in a kick drum for some reference. Maybe I should change the pattern here. And of course you can still, just as before, play around with all the settings and all the features on the front panel here. At this point, turning the blend knob to the left doesn't really make that much sense, because there's not really a signal at the input. We can hear this burst of noise, but well, that's not very interesting, is it? You can still do the same thing as before for creating, for example, pitch vibrato. Of course, there's nothing stopping you from combining both the pluck input and the signal input, but that's something that I leave to you to experiment with. Another thing that I quickly want to show you is that you can use delay 1 just by itself as, well, kind of a voice when you start patching feedback. I will turn down my mixer channel quite a lot because this can get very loud. So I'm taking the spare output here, just sending it into the input. Let's bring back the feedback knob, well, somewhere here. And then let's use this one. This mainly controls the feedback at this point because we hard patched, well, the feedback. So at this moment, there's nothing going into the signal input except for the output of the delay itself, and I'm not even using the pluck input. And as you can hear, this works just fine. You even have a little bit control over the timbre here. I'm not sure if I switch this to the left. Yeah, it depends on which input you're using to monitor and which input you're using to patch feedback. Sometimes some of these settings don't produce any sound, like here, but sometimes it's just reversed. And you can get it to saturate more by turning up the feedback and the blend knob even more. Let me turn down this mixer channel even more. But I think you can hear that, well, there's a lot of things to explore. Who would have thought that a bucket brigade delay would give us this gnarly bass sound? But enough of that. I will use this trigger here once again to ping filter 8. Let's use one of its outputs patched through the scope so we can see it just as before. And now let's, well, I still need to add this to the delay. So I'm once again going to use the regular signal input. Let's turn down the feedback for now. The blend knob has no effect because we're using the always wet delay output here. And the damping is turned down. Now we're not hearing the original sound. Well, maybe I should use one of these two other outputs. There we go. So now we can hear both the ping that's going in and the signal that's coming out of delay, which is, well, of course, a delayed version of the thing that we are sending in. And this is a very short delay. I think it's a maximum of 50 milliseconds. And everything about the speed of this delay is actually controlled by an internal temperature compensated oscillator. And this internal oscillator, the high frequency oscillator, has a frequency that's above 20 kilohertz, so above human hearing. And that's how Joranalogue was able to avoid the whine that's usually associated with bucket brigade delays, especially when you turn up the delay times, or in this case, turn down the coarse knob. You can use your own clock, but at this point, none of these inputs will react, because all these, of course, the fine and the time modulator, they all affect the built-in oscillator. So if we replace that with something of our own, these won't react. So I'm going to send in the odd output of a generate 3 here. It's in audio rates. And as soon as I connect it, you can already hear what a whine in a bucket brigade delay really is. It's really just the VCO that is used as a clock that we're hearing through. Let me turn down the frequency of channel 3, the one that's connected here. So this gives us this annoying whine, but you should be able to see, and I hope that you can hear it at least a little bit, that now the delays are much well, further apart. Let's turn up frequency again. So there you can see that we're getting one repetition, and as I turn the frequency of the clock source down, this repetition is happening later and later. Of course, we can also turn up the feedback. And well, apart from the whine, this is what you would expect a delay to do. Of course, this whine can be very annoying, and unless you filter it out afterwards with a low-pass filter, I think in most cases you cannot really use this, unless, of course, you well, use this whine to your advantage and just use it well, as a VCO. Now I'm sending in a pitch sequence to generate 3, which is acting as a clock source for delay 1. Let's tune it down. And delay 1 is really just still delaying the ping that we're sending in coming from filter 8. But because we are using a clock source that's within the hearing range, we also are hearing the clock source. And of course, the frequency of this clock source is now controlling the actual delay times as well. So now I'm tuning down channel 3 even more. So you can make all kinds of wonderful messes with this. One more thing about this high frequency clock. There's an input that we're using right now, but there's an output as well. Now when you don't have your own clock patched here, this one is just outputting the internal clock. So compared to the other waves on data, you can see that this clock is, well, really quick. It's really fast frequency. And as soon as you send your own signal in here, this will output that clock. And by the way, this always sends out pulses that are living between 0 and 5 volts. Why is this useful? Well, this can be useful when you buy 2 delay ones. And this would enable to sync a second one to the first one, even when nothing is connected here. No matter what modulation is going on here to the time parameter, the clock that is coming from this socket here will transfer all those changes to the delay that you connect this to. So this is going to be it for this. Well, it's not a short video, but I didn't go as deep as I usually go. There's also no sound examples. I said at the start of the video that I would explain a little bit about how this is possible, that I don't have time to do a deep dive. Well, I've been looking for another place to live for well over a year now. There are several reasons why I need to get out of this place. But it wasn't easy finding a new rental home to live. It was, well, actually quite frustrating, and it drained a lot of my energy over the past few months, especially. But long story short, finally I got lucky and I found a new home. Now, of course, moving house, it takes a lot of work. It's not as fast as just, well, snapping my fingers and I'm out of here. So the upcoming weeks or even months, I will be very busy transferring all my stuff to the new house and trying to deal with all the administrative BS that's probably going to happen between me and my current landlord. I'm looking forward to moving into the new place. I'm not really looking forward to all the work, but there's simply no other way. So I wanted to make some kind of video about Delay 1 for its release date, or maybe, well, close to its release date. So I hope by doing it this way you can get some kind of an idea. I didn't really go deep in complex patches and stuff, but I think by showing you these things that you can, well, have a first idea of how this module sounds and what the possibilities are. I especially liked the part where I used these two outputs as a stereo pair. I started modulating the time because that gives us all kinds of really cool stereo comb filtering, chorus, flanger effects, all that swampy goodness. Well, I hope you learned something. Thank you very much for watching. See you next time. Bye.